Okay, so our first example, we have already done this consumption model in section 3. We're just going to go back over it. We're talking about the battery division and motor division of a power source company, and you can just look on your notes or just follow along. But we have the batteries and the motors, and within here we know that the battery division uses 3% of its own, so we're coming out of B, the batteries are coming out of B, but then going back into B because they're being used. So that's 0.03%. Also, we know that the motor division, so an arrow back into motor division, is using 0.04 of its own motors because it uses 4%. So then for every 100 batteries produced, 1 motor is required. So we're going from motors to batteries, and that's going to be 1 out of 100, which is 1%, as a decimal is 0.01. And then from batteries to motors, we know from before is our 0.08, because that's 8 out of 100. And we took this in, we transferred this into a matrix. We're just going to go over that again. We have our batteries, motors, batteries, motors. So from batteries to batteries, that's at 0.03. And then we have from batteries to motors, which is our 0.08. And then we have from motors to batteries, 0.01. And we also have from motors to motors, which is that loop, 0.04. And just a little side note, this is called a weighted graph, and we're going to be looking at probably in the next chapter when we talk about graph theory. So you're kind of already being pre-introduced to a graph. Just a little note. Alright, so we already know that's just the setup of the problem. We're not actually solving anything, we're just displaying the information given to us. So I know it's cut off a little bit, but you've got it on your paper. There we go. So it says if 400 batteries and 100 motors are required for sales outside the company, find the total production required. So we're looking for our production, and they have given us the demand because it's what's needed. That's a key word here. Needed or required, something that that's going to tell us that that's how much is necessary for them to output or to sell or is needed by anyone in the economy. So we have our consumption matrix. That's right here. So I'm going to call that, I'm going to set up that equation here. So I'm looking for the production. And we know that production is equal to the identity minus consumption, the negative first, times D. Okay, so we had that written before, I just wanted to copy it back down. So all I'm going to do now is I'm going to go ahead and plug in my matrices, my 1, 2, 3, and 4 matrices. So the production is what we're looking for. We don't know how many we need to produce to meet this demand. So we're going to leave that as P1 and P2. And you could put an X and Y there. You could put a B1 and an M1, one for batteries, one for motors. These are just our variables, and we'll come back to those in a second. Okay, so the identity matrix, we know it has to be a square matrix, but it also has to be the same dimensions as C because we're going to subtract them. And in order to subtract matrices, they have to have the same exact dimensions. So this is a 2 by 2, so that must be a 2 by 2. So our identity 2 by 2 right there, minus the consumption matrix C, which we already have over here, 0.03, 0.01, 0.08, and 0.04. Okay, but that's all in parentheses because we're taking the inverse of it, so I'm going to put that back over here too. And then I need to multiply by the demand, which is a column vector, and the demand on top is going to be for batteries because we know batteries comes first, which is 400, and the demand for motors is 100.